They filter 20 liters of water in less than 25 minutes.
Wow.
Which compared to other filters, especially ceramic filter, it would take a few hours, let's say.
Yeah.
The other thing about this filter that's really miraculous is it requires no
you can
maintenance.
filter 20 liters every 2 hours.
So that, okay, you have a water
You
hose
fill
on
it
it.
from here.
Oh, you
See,
fill it on the top.
This is all the iron in the water.
Wow.
Because we get it from the well.
Mm-hmm.
And it's not a deep well.
You don't have this hose shouldn't be in the no.
Because you just fill until here.
You're not really supposed to hook a hose to it.
Yeah. It's not a continuous.
Okay. You just
Because
fill
you
it up
filter
on.
20 liters and then you have to wait a couple of hours
How
for the
long?
biolayer to regenerate.
And how long does it last?
Oh,
Forever?
forever basically.
Really?
And if it gets dry, then you just reactivate. The biolayer is something natural.
See, there's the biolayer there.
And by biolayer, you mean
It
what?
means we have sand. And the first 5 centimeters of sand, there are good bacteria eating the bad ones
How does the good bacteria get?
by themselves.
So when you put
They're
water in it,
nature,
you
just by
just
putting water. It takes about 3 weeks to fully generate a biolayer. Meaning after 3 weeks, then you can drink the water. You're sure it's
so you just keep filling it with water for
Yeah.
3 weeks, and then basically by that time
Yes.
it's self-sustaining.
at least 1 or 2 times a day.
Cool.
Problem is that because of all the sand, the water come out clean anyway. So people tend to drink it right away as well.
Right.
So big part of the training is to ensure they don't drink it within these first 3 weeks.
Or
Yeah.
if it goes dry and really dries out completely, they have to wait again.
Oh,
Yeah.
really?
I mean, we have people
Right.
moving to Thailand for work,
The water.
and then they let it run dry because they stay away maybe 4 or 5 months.
Right.
But when they come back, they just refill water.
And wait another 3 weeks.
So there are no moving parts, nothing expiring. Like
So do you
carbon
replace the
activity.
sand at all, or
Not at
just
all.
you don't have to? Okay.
Just had to wash it
It's-
sometimes.
So you get the bacteria removed. What about solids? Do you have to?
Oh,
still
well,
have
all the
solids.
solids, yeah, because of the mechanical filtration of the sand.
Okay.
But you can
So
clean
it's
the
like a
sand. What you do is you take out the diffuser plate, and you just take your hand and go like this. When you've got about this much water in it, you go like that, and you'll see this milky water come to the top, like when you're doing rice.
Uh-huh.
And in
Then you
that
scoop
milky
it out.
water are the dead bacteria and the
Oh, soil.
solids that you've got from the turbidity of the water. You dip that out, maintenance done. Back to filtering.
Do you have your Sumatra? Do you have your solids meter? We've been measuring all the water around here with our dissolvable solids
Okay.
meter. I don't know how accurate it is, but I do know that we've gotten a range of readings, and I was quite surprised. You know, you had brand name. I think it was Nestle's from Thailand.
Yeah.
It was like no better than tap water on solids, on solids.
Really?
Yeah, and then this other stuff, which is clearly they must do. What do you call it?
I mean, we have a full lab for testing.
Yeah.
If you see the lab.
We offer also commercial services for NGOs and stuff.
I think this is the only lab north of Phnom Penh.
Yeah.
Yeah, we found some of them. I guess it's parts per million on the dissolvable solids, but it was like 200 was around the.
That's enough.
But dissolvable solids doesn't necessarily correlate with pollution.
No. I know that, but we don't have any way of measuring that. So,
Yeah.
so I mean, this is our quick and dirty. Are they doing anything to the water at all? Because
73, 073.
Is that good or bad?
it's decent. I mean, we've seen stuff which I think they're using like reverse osmosis is down to like 7.
Okay.
Like I said, the Nestle's was like
Because for us,
200,
200?
which is, they claim that's about, normal for tap water. I don't know where they're,
we have a typical well. Typical meaning is 25 meters deep.
yeah.
It's quite a shallow well. Okay. Ideally, it should be at least 50 to 60 meters.
No, 70 is very good. I'm just, but our comparison is to something like reverse osmosis where like it's, almost not
And
detectable.
can you imagine? I mean, something so simple, something like you would say rudimental, and it's so effective. That's, I mean, the guy that came up with this design is a genius.
This is actually from the University of Calgary.
Really?
Yeah.
It's CAWST.org.
CO.
CAW.
Yes, Center for Affordable Water and Sanitation Technology.
Okay.
And it's,
So they put all the drawings online for free, all the training material, drawing materials for
Now
free.
this water, the,
Yeah, and I mean, obviously, it's not going to tell you bacteria and everything else, but
0, 0.
All right.
it's
that's good.
Yeah, that's why we are about this time. That other one 6, 7. Sometimes not good. They took up high, like over 100 something, some 200.
yeah. The Nestle's was the first. Nestle's was the first bottle that we bought, and it was like, I didn't know she had it,
But
and we
it's
stuck
still
it in there.
good for that number, yeah.
Well,
Yeah,
considering that, yeah, it's
Yeah.
as far as we know, it's the only feed that is suitable for Cambodian reality in the countryside. Does not require electricity. Does not require spare parts. Does not require to change something.
Yeah,
And it's so effective for bacteria, like 100%.
yeah.
The feed is 100% of bacteria.
Of course,
You're in a village,
bacteria is the stuff you care the most
But E.
about.
coli is
Bacteria.
whenever you find, we always find E. coli in our testing,
Really?
everywhere.
And it does work as an iron filter. And
So how do these go out? I mean, who gets them? And
Well, we have different ways. We have what I call like structured and official project. By
right,
donor like the Rotary or something like that.
right,
And that's normally a few hundred feet at a time. We selected the villages in advance,
okay,
and then we identify them. And we normally require contribution
Mhm.
from the beneficiaries just to give them a better sense of ownership of the filter. Other ones are smaller amounts done by smaller donors. We have a component commercial one. Cambodians actually come in and buy them for $60. That's mainly people in the Siem Reap area.
yeah,
Okay.
yeah,
And basically by now, since we installed that many, we have kind of waiting list. The chief of the village is calling us and say, "Can you come and install the filters in our village?"
yeah,
Okay. Maybe it's 300 households. And I say, okay, wait until I get a project. Because what you tend to do when you go in a village is to give everybody, not to give half of the village and half not.
right,
Then you start creating conflict within the village.
right,
Okay, so either you get together a few donors or you go to smaller villages. Okay, just to ensure that you can give one to everybody. Once they call us, also we tell them, okay, we are coming, but it's not for free. It will be $7 per filter contribution.
yeah,
And they normally agree,
yeah,
because if they don't, they say, oh, I'm sorry, I cannot come then.
yeah. Is this the name in the?
Of the organization.
Yeah, or-
Water For
I'll
Cambodia.
send, did I send you?
Is it online?
Yeah,
Yeah.
their website.
Okay.
Did I send you anything about the organization?
No.
I should.
I
If
give
I
you-
search on
will
this, I'll
give you
probably
my card
find it.
and we have the
Okay.
web address and everything.
Let's go look at the
other thing-
actual. So those are just the concrete castings
Just
over here.
concrete blocks. So what it is can be built with local materials or locally available materials.
This is cast in one. It's cast in one piece, or
Yeah, it's a very
Yeah.
clever piece of.
So we have there the molds that we use.
oh, actually,
You have to see the mold first in the beginning.
Mm. Wow, those are quite beefy.
See, here we have an empty one.
I built one in the States. All these molds.
Pretty thick
Yeah.
steel.
So we just put the copper pipe and then we fill the cement.
Mm-hmm.
They stay a couple of days in the molds, then we pull them out and we let them cure.
Mm-hmm.
And then in about 2 weeks they are ready to go.
What is this right here?
This one is to open up. Now the filters are basically upside down in the mold.
Mm.
Okay. And this one we have to untie all these bolts and this one to push it and come out.
Mm. Okay. Like an assembly line. You can see why you make them in big batches.
We can make 10 per day.
Yeah.
That's our ideal capacity. If we need to push it a little bit more, but that's basically it because we have 20 molds. So it's either 20 a day, or 10 a day, or 20 every 2 days. The sand we will use is on the other hand. The sand we use for filtering, in theory you can use any kind of sand.
Yeah.
Then of course there is this sand which comes from Kampong Spur.
From where?
From Kampong Spur. Down in the south, it's a province down south.
Okay.
And it's the best for filtering purposes. The size and the dimension and the shape of the sand, it's the best.
The sand is very rough,
Mm-hmm.
on a microscopic level, so there's room for bacteria to hide in the cracks,
Right.
crevices of the sand. If you get a sand that's been river washed,
Yeah.
it's all smooth, the bacteria doesn't stick to it as well.
Yeah. Yeah.
You can see the diameter of the thickness of the concrete,
Mm-hmm.
so even a 1-inch shaker is too big.
Yeah.
And we searched and searched for a smaller shaker, but there's no need for it.
Right.
But it was amazing. The guys were beat them with hammers to make it settle.
Right.
And when we stuck the shaker in, it dropped about that much, and I can't remember the guy's name. He's a really nice guy. He was like, "Whoa!" I can't, because he thought it was really compacted. But the problem was that the shaker not only didn't fit very well,
Yeah.
but it's hard on the forms
Oh yeah.
because it rattles against the side of the forms. So there's a real issue with slump on the concrete. So they're not pouring a high slump
Mm-hmm.
or a low slump, however you want to see it, a low numbered slump,
Mm-hmm.
because you can't get it to go down in the forms. So they're using a higher slump.
Does that mean it's more watery?
Yeah, it's more watery,
So it can flow into the.
which is why it's so nice and smooth, so it flows in.
Yeah.
So, but there's been no problems with them. The question was 2 or 3 years ago when I visited, long-term, are there any long-term problems? But there've been no long-term problems,
Yeah.
even though they're pouring like a 7 or 8 slump. Whereas I thought they should be pouring like a 4 or 5 slump, but I was wrong. Because you can't get it to go down, because you see the form stops there, piece is inserted, so the concrete has to go down around the bottom of the.
Mm-hmm.
We put the logo of the donor. We give them an ID number, a unique ID number. GID is just a dropper. That's the organization that founded these filters. We put the construction date and our telephone numbers in case there's a maintenance or something goes wrong.
What's the Malteser International?
Malteser, it's another NGO. We are partner in this project. We do the filters, they do the latrines.
Okay.
and drinking, and they 3 wells as well. Big bags. Easy to wash, need to buy far away because, as I say, we never need to change. Just washed. So once it gets here,
You say south.
yeah,
South of even Phnom Penh, or
yeah. So,
more towards the
southwest of Phnom Penh.
coast? Okay.
And here's where we wash it. See, this is all the thin part that come out of the sand. And the actual sand is this size.
That's before washing.
This is washed.
Okay, that's washed.
Because also you don't have to wash it too much.
Okay,
You
so
wash it 2 times. We put
trying
in
to
a
get
big
the
bassinet,
fine-
let the water overflow,
uh-huh.
and that's it.
Okay.
Otherwise it will become too coarse.
Yeah.
And these come from a, how you say, a quarry.
Yeah.
They dig it out. Part of these baths that we provide. Because one of the biggest problems is a cross-contamination of water.
Yeah.
The water come out clean from the filter, and they put in these buckets, paint buckets, and then they would just dig the jar or something to get the water, which was laying down in the ground,
Yeah.
and they will contaminate everything. Whereas like this is too narrow for that, and then they have to use this spigot here to actually get the water. We go install them, and the moment we provide some training before we bring the filters, the first visit in the village. Then we provide training when we install the filters, and we require somebody from the family be there,
Yeah.
so they actually see what we're doing. Then we provide another training 1 month after we install the filter. That's when we collect also the first water sample, just
Right.
to check everything is okay. And then at least one more, almost 1 year later, when we go again for the final.
Good.
Unless during the year they call us for specific problems.
How good are they at following the directions?
They tested. They did a test last year. I think 86% of the filters were being used properly after 1 year.
Good.
It's just phenomenal.
Well, let's say 86% were providing safe water.
Yeah.
Even if they were not using that properly.
Mm-hmm.
I mean, the main misuse is they filter too much water at the same time. Or they try to connect a hose directly and like continuous filtering, which is not supposed to be like that.
How do you filter too much water at one time? Are you
By
supposed to?
pouring your 20 liters, half an hour is done, and right after you pour another 20 liters, then another 20. Whereas you're supposed to wait about 2 hours between one pour and another
I see.
to give time to the bacteria to
Yeah.
regenerate themselves. Yeah, they get tired.
They're
The
not.
Italians
I
want.
always think of
They're not ready
that
for
game,
dessert.
Pac-Man.
Yeah, that's right. Here we go.
They what?
GPS locator.
Oh, you get coordinates for.
So when, like we put out filters the last few years.
Yeah. So you have a map of everything.
They have a log.
Yeah.
Which shows the number of the filter and where it's located and the GPS coordinates.
Good.
Yeah, because to do the monitoring and the surveys, we use an app.
Uh-huh.
And between the different questions, the app also has the option for pictures, for taking GPS coordinates, and so on. That's really helpful. Compared to all the, to before, everything was done on paper and by hand,
Yeah.
which was a disaster. I mean, even the GPS coordinates are long numbers, eh?
Yeah.
It's so easy to write something else.
Right, the wrong way.
Well, that's an ideal app because you could actually call up the map.
Rotary Club of Bath, that's my rotary.
And who's this guy, the founder?
Founder.
Okay.
So there's very few labs. that do water testing in Cambodia.
Mm-hmm.
This is the only one really north of Siem Reap. So they test, the other water filter company in town, which is called Trailblazer, actually tests their water here. And Malteser and a lot of the NGOs test their water here.
The testing, in the last 2 years, actually, the tests have found a source of funding for us. So start getting money directly in Cambodia rather than just relying on donation. Okay. We are the only lab out of Phnom Penh, so all other organizations providing other kind of filters, drilling wells, working with water. Sooner or later they need to know which kind of quality of water they have, so they come here to test. So this is pretty good for us. Initially the lab was set up with a contribution from the Bridgewater State University and I think, no, University of Victoria. The professor that was there was a guy from Portland actually.
Really?
Yeah, he taught several years there in Colorado and then moved to Vancouver and then moved to the East Coast. Yeah. That's why when he got in touch with all the people from Rhode Island. Yeah. So, yeah, this is it.
And what do you test for? So bacteria and...
We test several parameters because for hotels and guest houses, they tend to ask more tests towards their swimming pool, for example.
Oh yeah?
Whether it's clean or not. So, not strictly drinking water. There we go. These are all the parameters. So we test pH, turbidity, conductivity, salinity, TDS, calcium, magnesium, nitrates, phosphate, iron, manganese, arsenic, free chlorine, and then the bacteria. E. coli, total coliform, and Enterobacteriaceae.
And how long does it take to do a test? Full
Well,
test?
most of the inorganic parts are quite quick, fairly quick. The longest one is for the bacteria because it has to stay 24 hours in the incubator.
And then how do you actually detect the bacteria?
Oh yeah,
What
because you have an old disc. See this one, you put water inside here, this disc where there is a reagent, and then we come out spots that should actually count. Because the standard for E. coli is 0,
Right.
so there should be 0. This one was 0 E. coli and 12 total coliforms. There's a lot of bacteria that are always present, but it's okay, they're not dangerous. Sometimes there are too many to count. That's a big problem.
Not good.
Yeah. So. Yeah, so normally they bring us the samples one day, the next day we give them the results.
How much do you charge for like a hotel to get their testing?
For a full test, like to know if the water is drinkable, it's $42. So, and that's normally you really do the very first time that you test that water because we have several customers testing the water every 3 months. Now, once you know that it's always from the same source, and now you know that you have problem, for example, iron or manganese. So after that, you just test for those 2 parameters. So maybe you spend just $5. Okay.